So my name is Jeff Lombardo. I'm a security and identity specialist at AWS. And today I will talk with my peer over here.
Hello, everyone. This is Fei. I'm principal engineer in Amazon for close to 10 years. So I'm the lead engineer of Amazon Cognito on the service team. And happy to be here.
Thank you. So today we will talk about a topic which is onto a lot of lips of our customer, which is the right way to secure AI agent. And thanks to some things that we have built with Fei, we will have some code examples in order to show you how you can bootstrap that and you can try to sort it. So I hope you will be interested into that. So first of all, we just want to make like a little bit of a retrospective about what GenAI is of today. Because we cover a lot of ground over the last 3 years. We went from just the era of POC where customers were just like starting to create some small example of chatbot and maybe a little bit of RAG there and there, okay, to the era of prediction. So the ability to start to look forward, to find the needle into the haystack, and to try to provide more value, more insight to your own end user and your own customer. And in order with this added value to expect to go faster onto the innovation and push forward. But now customer wants to bring even more value, and we will see how. Data will be like a very big and important state into the way that we are moving forward. GenAI has been created and is fueled by data. And that's where those GenAI agents will play a big role. The idea beyond that is to be able to pioneer our new ideas and our new services that you will offer to your own customer. So here we have just put a little bit of schematics about what is a GenAI application today. What we found is that we have users, we have authorization servers because those users needs to authenticate in order to be able to operate with our application, okay? And once they are authenticated, they will try to provide an input to our agent, which is the part within the GenAI application that will have to deal with those prompts. And generally what those agents are doing first is that they try to enrich the prompt with some information that has been pre-normalized into a language that the LLMs are talking, which are like vectors. So your data set has been put into vector database and the agent will grab more information from there. The next thing is that this enriched prompt will be provided to the LLM for the LLM to be able to provide an answer and potentially to also perform some actions through some custom logic against some external services like a communication platform, whatever it is, a Slack, or a Teams, or an email system. But what we found with and then for sure to return the answer to the user. But what we found is that there is a lot of untapped data. Okay, you have business data, you have employee data, you have consumers data, local data in some use cases. And what your LLM wants is to be able to use that without necessarily requiring you to normalize all this information, which is generated in real time and at a large scale. So that's why we saw the appearance of what we call AI tooling. And those AI tooling are here to create the interface for your LLM to be able to consume from those untapped data store and to be able to provide, again, added value, outcome, and answer to your different users. And the things that we see now within enterprise is that we have a need for zero trust into all of that because we have like many users that are talking to many agents, that are talking to many data sources, and we want to be sure to provide the proper authentication and authorization in between all those paths of the communication. And what we also want to do into that is that while we are progressing from the user to the data, to be able to narrow down and reduce the scope of action to be fine-grained at each level and to enforce the right mechanism. So today, that's what we will talk about through our talk. We will talk about JSON Web Token coming from the O2 framework. We talk about the ability to exchange those tokens for like more scoped token, okay? In order to demonstrate how we can effectively expose those data and use those data with an LLM. For that, we will use like something that you might have heard recently, which is the Model Context Protocol, also known as MCP, which is the new technical specification for builders to be able to create those AI tools. So this specific specification is building again on OpenID Connect and O2, which are exactly what we will demonstrate today, and we will show you the value of this specific framework. If you want to do that after this talk, what we have built today is already available. We will use this specific solution of guidance for MCP server on AWS, and we will use the QCLI, which is now supporting MCP server configuration. So you will see all of that in the code talk of today. So let me give a little bit of rundown about what Faye will talk to you about. So we will use Cognito for the authentication part. We will also see how the tool are registering themselves to the agent. Again, the agent and the application in our case will be QCLI. We will see how the user can provide an input, how this input can be sent to Bedrock in order to be resolved, how Bedrock will make usage of the tool, and the two tools that we will use today are a weather tool and a travel agency tool. And those tools will allow us to enforce the right amount of access control, okay, potentially requiring a new set of tokens that are more narrowly scoped. And then we will see how we can access to the backend services in order to be able to deliver the value to the customer. Okay? Sounds like a plan? So, yeah, and to return the response. So, Faye.
Thanks. Thank you, Jeff. When Jeff was talking about MCP, I saw a few of you were nodding your head. How many of you are familiar with MCP or heard about this? Almost everyone. And then OAuth. Have you heard about the OAuth with MCP as well? Okay, that's good. So our team has been working very closely with MCP on the OAuth spec, and we can talk about that maybe after the meeting and things like that. But I think one of the main goals of this talk is to help you understand how we would write code to secure your application, user application, MCP client, MCP server, all the process behind. So that's what this code talk will go through, and I will divide it into 3 phases to show you. The first iteration, or maybe the first phase of the code, here we focus on the weather tool. So it's the same diagram as what Jeff showed you before. We focus on Alex, for example, signing in with a Cognito here. Cognito is an identity provider, and whatever you see here is applicable to other identity providers as well. So if you want to use others, fine too. Alice will sign into Cognito, get an access token, and Q is the agent here. And then Q will talk to Bedrock. Again, Bedrock is an LLM model, which you can also substitute with something else if you want. And then use that token to access the weather tool. So it's a very simple flow. The weather tool here is a public service, which means OAuth, and that's not required. But at least that's the first phase I want to show you, and then we'll get into more sophisticated one. For the code to work, there's a couple libraries that you will need to set up. Hono is a library where you can use it to host HTTP server proxy, and it's a convenient to validate OAuth token as well. And then you have the handle, you have sub-libraries from the Hono here. So for the MCP to work, this is the code that if you want to run an MCP server, obviously, you need some kind of server in front of the weather tool, right? We talked about the 4 parties. Just keep that in mind as we go through the demo. It's very important. You have a user, you have an application. Application is also the agent in this case. You have the MCP client, you have the MCP server that's a proxy to the resource, and then the weather tool. So 4 parties, because authentication, propagation, all the things, they differ across these 4. So this is showing you what would the MCP server do. It will be handling a post request when someone sends a request to MCP. And then inside this post request, this talks about the protocol part, where it will instantiate a transport object from stream over HTTP server, connect to it, and then get a message. So it's more of a boilerplate code where you get an incoming message, was sent from the agent to your MCP server. You'll be writing that. And then the handling will then route to the different tools. Excuse me. And then the MCP server is protected by OAuth. This is something that I'm not sure if you noticed that in the latest draft of the MCP spec, we talked about OAuth separating that as authorizing server separate from the MCP. So MCP, think about it as a resource server where you are taking requests to access a resource, and then the token is someone who presents that to the MCP server. You know how to access that. So here's a code to validate the incoming token before the MCP server said, OK, I allow you to access the weather service. So it's sitting in the middle. One of the OAuth token is getting from Cognito to the weather tool. And this diagram shows how the token is getting retrieved, obtained. Couple of steps. Q as an agent first request it wants to talk to weather tool. So weather tool will tell it, hey, you need a token, you need access token, and then that will route the user using browser to the Cognito as identity provider. User will see the page, hey, please sign in or please register. And then once Alice signs in, and then the Cognito will grant a token, will grant an access code to the weather tool. And then eventually, you will also get an access token from there. We send an access token to the weather tool, and then the weather tool will send the token further back to the authorization server. So here we talked about a weather tool is a resource here, and we need an authorization server to protect it, which sits somewhere else. So the purpose of doing 6 and 7 is such that because the Cognito token comes in as an access token, but it's a different authorization server from the weather tool's own. So that means the weather tool will send this token to its own authorization server to do the validation and then sign it and then give it back. It looks probably a little bit redundant from the slides, but the important thing here is that so that it can the weather tool itself can trust the tokens that are validated by its own authorization server, right? Because just because it's authorization server, just because it's access token does not mean that you can take any access token from the world in order to use it. So you want it to be validated by your own authorization server. OK, and then this is the code that shows how the tools function, how the MCP server tool you would do. It's pretty simple in the sense that you take an input as a 2-letter state code, and then build a request to your backend resource server. In this case, it's the weather tool service, which is public. The method here, beside this tool method, there's a declaration about annotations. Yeah, so I probably should talk about annotation. Get weather alerts for state. These are the information that teaches the LLM model about what tools is available in order for the LLM model to give you instruction or give the agent instruction to move forward. The next method shows you that's a request where you just construct a regular request and send it to construct a URL and send it to the weather forecast service and get a response back. Right. So that's the first part of this code talk. I will hand over to Jeff to show you the code.
OK, so the solutions that we are using, like I said earlier, it's a solution that already exists, which is like the AWS guidance for MCP server on AWS. So for this first step, we will just use that and try to go a little bit more into the detail over here. So the first thing that we know is that if we are looking into the configuration of our QCLI, QCLI since recently now support the definition of MCP server definition. Okay, so here you can see that I have deployed my MCP server as a Lambda function. It is exposed through a cloud front endpoint, okay, and I can make aware my QCLI of it because I'm configuring this specific mcp.json file. Okay, so now it means that if I'm doing some QChat over here, okay, I will just bring that back. Oops, sorry. Come on, ready? Over here. Let's go back to terminal. So if I'm going over here, I can say, for example, book me a plane ticket to Boston if there is no weather alert. Okay, we just saw from Faye code explanation that we have like the MCP server is capable of giving weather alerts, but we want to do like a full trip. So let's see what happens with that. So QCLI is thinking about the next step to do. He say, I cannot book a flight. Okay, so I will say, that's not a function of the MCP server. Can you give me the alert weather report for Boston? And let's see what goes with that, because that's a function that that's bizarre. Okay, let's try again. Beauty of demo code.
That's the beauty of doing live demos.
Yeah. Oh. Oh, thank you. Okay, so it seems that there is an error into my MCP JSON file. Thank you for the person that follows on to that. Line 11, where is that? Line 17, where am I? Okay, let me try to do that. Did I find something? Yeah, thank you for that. So I should have, if I do that. Thank you. Now it works. So you see, it's starting to try to evaluate, and that's what I was looking for. So now he's sending back to Cognito, and he says, if you want to talk to the weather chat, to the weather MCP server, you should be authenticated. So I will authenticate, and he will say, okay, I have authenticated you, so you can return to the CLI. And now if I didn't make resume, so give me the weather report for Boston. Okay, so you remember you need either a state or you need some longitude, latitude for information, which is exactly what he got from for Boston. And if I say yes, then my LLM, this is just, we are just using Bedrock over here. So Bedrock has no live information. That's really the MCP server answering with those information. And if we were in Boston, that should be the weather on top of you. So from what you saw, we have made an authentication through Cognito, and we are capable of talking to the MCP server because we have an access token, and the LLM can benefit from the information of the MCP server to be able to return a value to the end user.
There's some animation.
Yeah, that was
skip
just
that. Okay, so that was the first step. You saw that the MCP server was authenticating, authorizing access. The weather service itself does not need specific ones. It's more of your MCP server in the middle is authenticating, authorizing the user. Because when you build some service like that or agent or MCP, you don't want everyone to hit in your endpoint in the world, right? You want to control that to a good degree. So that was the first demo. The second one is about the travel agency. So now let's talk about travel agency. Travel agency is another service out there. And that one, the first method is to list all the travel options. And for this method, it does need an OAuth protection. And you can see that it's a standard open API, and then there's a scope that's relevant here. It says MCP/server/read. So the name is probably not the best. You could imagine that should be called maybe travel agency.list all, something like that. But that serves the purpose. So there's API out there, and now you want to add some code to your MCP server in order to interface this while still authenticating user. So the way it works is that the travel agency API is a mocked API, and what it would do, which is I think this is probably normal or what you would expect, is that it will validate the incoming access token, JWT token that issued by Cognito or by some other IDPs. Especially, it will look at is the client ID. Client ID is the MCP server, because remember this access token is for the MCP server to access the travel agency. It's the second hop. So it's from user to application, application to MCP server to the resource. So the client ID is the MCP server. And then the scope is MCP server./read, which is equivalent to the travel agency list. And then the sequence here is very similar to the previous one, except that we have another arrow from number 3 to number 4, which also not only gets weather alert, but also tasks the travel agency to get all the travel options. So it still goes through Alice signing to Cognito, use the token to access Amazon Q as an agent. Q gets instruction from Bedrock on what to do. Bedrock will tell it to get alerts and also list the travel options from the agency tool. So here are the functions. Here's what's underlying the hood of the MCP server for the travel agency. Yeah, and then you have a list of you have a description of what this tool does about list options, and depending on the origin destination, it will give you the options here. So this is the method of how it handles incoming requests on list travel options.
And what we are doing here is that we will send this specific request to the backend services. And as you can see over here, we will do a post, and we will use the access tokens that was provided to the MCP server, and we will pass it as a bearer authorization token to the backend service.
Yeah, which is something that you didn't see on the first part, because first part, we did not need to pass the authorization access token to the weather service because it doesn't care about that. But this one, it cares. So here, you see the authorization header is to pass in the access token for MCP server to access the travel agency, which is probably somewhere in the middle of the screen. All right, I'll pass back to you.
Yeah. So we have already deployed the travel agencies that along the API specification that Faye talked about. So what we will just do over here, now that we have corrected the typo into our mcp.json file, is that we will edit it, okay? At the end of that, we will just add a comma, we will just paste the travel agency MCP server configuration. So what we will do is that we will configure this additional MCP server configuration over here. And what we will do, as you see, it's another Lambda function. Okay, it's deployed beyond another CloudFront distribution. So now, if I just register that and go out, sorry, what? Okay. I'm glad we have people following today.
I think we should invite you up here. Thanks.
Yeah.
Thank you.
We are recruiting, by the way. Okay, so that should be fine now. If it does not work, is this gentleman issue? It's not mine, okay? So now if I do Q and I resume from where I was, because QCLI is capable of doing that. So you see that my new servers popped up for an authentication, but because I had already a session at Cognito, nothing happened. Everything was done into the backend. Okay, so now I have my two servers. So you see, we discussed about the weather in Boston. So Q, keep memory about what I said. So now if I said, okay, if the weather is okay in Hawaii, yeah, I can do some typo. Book me ticket from Montreal, which I'm based at, if you didn't get it yet, to there from June 23rd to July 10th. Okay? So let's try to see what happened with that. Okay, so first he understood that he had to check the weather in Hawaii. So he took surely Honolulu. He will go over there. We'll see what happened. So he's looking at the flight condition. You see he already generated the request for the right date, departing, arriving, coming back from the right city. So yes, let's go with that. And that's the second MCP server, the one that is using the access token and passing the access token to the backend. And you see return to me like a certain number 5 or 3 option in order to be able to go there. This is all fake data. Don't look at those price. That's not what you will get. Okay? Did he book it? No, because he don't know how to do it. So Faye, how can we do that?
I don't know. Let's get to the third tool to get that. Okay, so that's the third step is about now we need an action. That's more of a write action, right? We saw the one without permission, without explicit permission. We saw the one with a list. You do need a permission, however, that's more of a read only. The last one is about let's ask the travel agency to be able to book a ticket. And that's the last number 6 on the diagram where Amazon Q tasks the weather tool, tasks the travel agency tool, getting the list, getting the options, and then do the booking on number 6. And here is the definition of the API/book. The scope is different. There's a scope MCP-server/book, which probably you'll notice how we want to use it. The important thing about the third one, this one, is that the top part about read is the same. Is how the travel agency listing API is going to validate the request by looking at whether it's a valid JWT token by Cognito, whether the client ID is the MCP server itself or MCP server who's sending the request, and the scope has MCP server/read, which I talked about is more of a listing. The second part is where it's different. It needs to do a couple of things. It needs to ensure the scope is MCP-server book, right? That's a different action where user wants to take and agent wants to take. And I think there's something that we will, maybe that's more of a quiz. You will see whether this is a complete or not. So there's some of these scope that need it. But you can see there's a difference between the book and the list, where the authorization server and the resource server takes. Okay, so from the functions point of view, that's how you would write the MCP server to take requests to do some booking. And here, I think the method that's interesting is the make travel agency book request. The body looks mostly the same, passing a parameter from the inputs of the MCP server back to the backend resource server. And then the code here is similar to the previous one, where you have the current OAuth 2 token from what MCP server obtained from the Cognito, and then sending in the header, forward the request to do the booking. All right?
Yeah.
To you.
So you didn't saw it into the background, but I just it's infrastructure as code, so I changed the code of our travel agency MCP server to do that. So the thing that we will do is that we will just quit QCLI, and we will just redeploy through CDK our stack, because the solution that we are using again in the backend over here is the solution from the AWS guidance on MCP server. We have just added some element onto that. So he detected that the travel agency code for the Lambda function changed, because now we have another function onto it, which is the book function, and he's currently making the change to those different resources. So because we want it to be protected on the cloud front, there is some WAF ruling onto that. That's what you have seen a little bit earlier. And then it should change the Lambda function right away. And then we will be able to go back to the QCLI. And the QCLI, again, should have memory of the previous conversation that we have. So I should not have to require to ask for those options again. So Lambda function is deploying. And the whole API was already over there. We did not deploy the API. We are just like onto this MCP stack. OK, so it's deployed. So let's go back to our queue chat. We don't need anymore to change the MCP.json configuration. We already have authenticated through Cognito, so he knows where we are. So now I can say book option 2. And because he knows what I have asked as a travel option for Montreal to Honolulu, he will try to do it. So let's try. Oh, I think there is an issue, Faye.
There is an issue.
I think it didn't work. So can you explain us why?
Can someone help us to?
Sorry, what?
I was asking someone to help us to.
Oh, can someone help us? Why did it not work? Over here. Yes. Yes. We had a scope, but not the right scope. We were using the read scope, and we need a book scope, like this API documentation tells us.
Right. That's one. There's another reason, which I will show as well. So that was the first reason is that it was missing the scope. It was just sending the initial token as is, which is not right. The second reason is that it's missing the user. Right, so when we send the token over there, the token itself represents MCP server talking to the resource server. That's a machine-to-machine authentication. You get a 2LO, 2-leg flow OAuth token with a machine identity. And when you need to call an API on the backend that has machine and user, don't lose one of them. You need both of them. In fact, this is something that I'll probably talk at the end of the slides about the importance or the things that AWS is thinking is very important for people to build their applications. So it's missing that act as claim, which is a user. And also the scope was wrong. So this is the part that shows it's more of a handling the error that if you were writing a resource server on your side, and then you see that request coming in, there's a missing scope on, for example, book, then you will throw a header about triple double authenticate, and here's a bear is missing some scope. So that's more of a code of what you would write to return some response. All right, so this is probably one of the key steps of what you could do to fix that. The token that you had was a machine-to-machine token proving who the MCP server is to the travel agency, but it's missing the user information. So what you can do is that you can do an authentication when you do an authentication as MCP server to get its own authentication token, M2M or machine-to-machine 2LO, it will run the token exchange or similar token exchange where it first gets its own client secret, who it is, and then set the body. So set the initial user token of representing who Alice is. That is the token that you send into the AWS underscore client metadata. So this is a feature where maybe some of you are familiar with the Cognito Lambda or pre-token generation, where you have the control of, at the time of the machine token generation, you have the control of injecting your own information, data to that, so that the token will come out with claims that you want. So this is what this function does. By doing authentication and sending AWS client metadata of the current user, the user who initially signed in, once you run this request, then you will have a token of what you want. So the part that I was just mentioning about is a new feature that Cognito released probably a month or 2 months ago, where there is a pre-token generation where you can tag your own code to customize the output token. This also now works for machine-to-machine generation. So it is a good match for this type of application where you have an agent and you also want to have a user. So it's two combined information into one. And an earlier time, we had the impersonation. That was probably last year or last 2 years ago.
2 years ago.
Using a custom auth.
Yeah.
There's a difference in the concept between delegation and impersonation. Maybe this is more of a terminology. I want to talk about it a little bit. Impersonation means you are sending your user's credential as is to some services. And when that service sees this credential, for example, when that service, maybe the travel agency, see the credential that, let's say I send Jeff's credential to the travel agency, the server will not know if it's Jeff himself doing it or I'm as an agent doing it. So that's impersonation. Impersonation is applicable in many cases, but it's also very risky in some sense because you're missing who the agent is. Delegation is where we show here that the actor who's doing this request, we talked about the machine-to-machine authentication, getting the OAuth token to represent MCP server, is still the agent. But the agent will have an additional claim to talk about Alice that's in the token itself. So that's a delegation. In the agent world, in the agentic world, please look at the delegation, and that's the approach you should prefer as opposed to impersonation. Okay, so then this is the part that takes the request. Once you have that token back, and then you use the token to make the booking with the travel agency. I'll show you the token content on the next slide, which probably this.
Right after the demo.
That's after.
After the demo.
Okay,
yeah.
after this. So let's see the demo.
Okay, so like last time in the background, I just updated my Lambda function code. Okay, so what we will do is that we will just deploy this new stack. You know the drill about that. You know it takes a little bit of time. So in the meantime, while he's doing that, what I will do is that I will talk a little bit about what Faye just said, how we can enrich token. Okay, so inside Amazon Cognito, you have the ability to have some extension Lambda trigger. In this case, the pre-token generation Lambda trigger, which can allow you to enrich access token and identity token. It was only for user-based flow. Now you can have it for machine-to-machine flow. Okay, and as you can see, for the moment, our Lambda function does pretty much nothing. Okay, the tokens that came in is the tokens that goes out. So what we want to do is to be able to upgrade this specific function to be able to do what we want in our case. So let me just. So I will just upload my new zip file over here. It will deploy it. And we will parse it very quickly together. Okay. So what happened is that when this function is called out, we will use a token JWT JSON Web Token verifier for a certain user pool, a certain type of token, and a specific type of client ID. And if the verification is okay, we will tap into the payload, and we should add a specific claim inside the new access token, which is an ACTAS. And this ACTAS should bear the subject and the issuer of the initial token that was sent as part of the token exchange element. Okay? The scope is part of the token exchange request. Okay, so it should follow up into that. We will see that later on. So let's go back to our deployment. Okay, the deployment is done. So let's go back into our resume. So now, if everything is okay, our MCP servers that do the booking should be able to understand if the backend API is sending a 401 with an indication that the scope is missing, to just do a token exchange within the MCP server and retry the request with the new set of token. So now if I say book option, I don't know why, I just change of option. So it will, again, think about memory about what we were discussing earlier. If I do yes, okay. Now he's trying to do it, he's talking, great. Just bought our flight. We are ready to go to Honolulu, okay? So, Faye, can you drive us through that?
Yes,
please?
Of course.
That was just the animation of what you just saw.
5 hours. So the flight was pretty fast from Montreal to Honolulu.
Oh, yeah.
Should be more than 5 hours.
Innovation.
Okay. All right. So this is what the token looks like after that Lambda function, where you have the client ID and the subject. Those two represents the agent identity of the agent, or the MCP server in this case, because they are living together in our example. And then the act as is where the user information is. And act as issuer is Carnito. Carnito issuer the subject, which represent the user identity, and that part is added to this token and signed. So the important thing here is that because the client, in this case MCP server, has authenticated itself, and because the MCP server is presenting a valid user token from a source that you trust, you are the application developer, you are the admin who develops it. Once they have these two pieces of information, then you validate and you sign them, put them in the token. That's the one that you issue to the travel agency booking service. So when travel booking service sees this token, it has both information. You can log, you can observe, you can reject, you can scope down. We're not showing some of detail over there, but obviously if you see this, is this user maybe coming from this or this department, or this user has this kind of attributes? Is this agent who developed this agent and all this metadata? You can think about that. Those can all be part of this information where your travel booking, the API can use this information to scope down or control access. That's a pre-token generation Lambda that Jeff showed you, where this is doing something that's pretty simple. It's more of a validating token and then looking at that information from the client metadata that's passed in, and then generate a token and add in those new claims. Okay, so I want to summarize a little bit before passing back to Jeff. A couple of things that are important. One is so we were talking to customers this morning. We had some customer meetup and discussed. First of all, there's a lot of a myth about what is MCP server and what's the security about that. I think the way that I would describe is that if you're building a backend service and access your resources, would you open a backend service to the world as is without protecting? No, you won't, right? Because you still want to authorize that. So I would look at MCP server as a backend service that you want to protect. And the second way that I would look at that is that because when there's an agent, whether that's a QCLI or someone writes an agent, want to talk to an MCP server in order to talk to the backend resource, assume it's rogue. Do not trust that the agent pass you some parameter as is. And that's also the second part that's important. So here, the example we're showing is that why did we spend all the effort of getting an OAuth token, JAR token from Carnito, do the pre-token generation, sign it, and then send to the authorization server to MCP? The reason is that because it will reduce the middle person from tampering it. Because your agent, if you don't trust the agent code or the MCP server somewhere in the middle, you don't want to trust that it will tell you whatever user ID you want to retrieve. So that's the reason why we have all these things come together. And then the third is that there's a two, in most of the cases when the agent is acting on behalf of someone, there's two identities in the play. There's a agent identity itself, or machine identity, and there's a user. So make sure you track all of them and then forward them to the resource server. And most important thing is that resource server is the one matters. So in our discussion with customers think about how do I make the agents sophisticated, or how do I control that, all the things like that. You don't start from the agent, you start from the resource server. You start from your assets that you want to protect your company. And that asset needs to be able to look at the request that if you don't show me a request, showing who you are, who you're acting on behalf of the user, and then showing the proof that they are the ones that someone issued them. Must be IDP or someone, a third person that's authority that can issue that. If you don't have this information, you as a resource server should reject the request. Simple as that. That's not the same as a lot of microservice architecture, which I can talk a lot as well, where you have multiple services talking to each other. They have a trusted bound. One A talk to B because it's coming from A. Do not trust just because it's coming from machine A. So I think this is about what we are covering. We come from the authorization flow, from all the way to the user talking to agent, and then talking to the MCP server in the middle, and then talk to the resource. Just step-by-step of propagating user identity, authorizing, scoping down, and then at the end, we also run a token exchange in order to mint them together to present to the travel agency booking service. Yeah, I'll pass back to Jeff.
So if you want to be able to build the same thing, again, what we used is already public. The only part which is not is the travel agency code, but we might push that through a pull request onto the repo. So go to the AWS guidance for MCP server on AWS. You will find the GitHub repos that will bring you to the CloudFormation template and all the code that goes with that. If you want, so you can build your own MCP servers. But if you want also to use MCP servers that have been built by the community, you will also find to the second link, which is on this slide, about the list of MCP server, which is still growing, that solution architects are doing for you to be able to interact with any AWS services that we have. Also, I want to highlight the fact that a few weeks ago, we released our open source AI agent SDK. So if you want to build something that look like, feel like, and has the force of the QCLI, you can already do that by yourself. Through this open source SDK, we have made it super easy for you to build your own GenAI application, your own agent that support the MCP protocol and can provide far more value to your own customers. Finally, I just want to bring you one slide of all the magnificent sessions that we have onto this topic. Here you are onto the code talk, but we also have some builder session and some workshop if you want to have some hands-on onto those technology and even go even deeper into the authorization logic, because MCP servers are like intelligent API gateway. They need orchestration logic, and they also need access control logic. So please, if you want to go deeper, follow those sessions. On Wednesday, Faye and I will have a lightning talk onto the same topic. We will cover a little bit more ground onto the standards that are governing MCP. And if you didn't get enough today, you can still join us for a repeat tomorrow onto the same topic, or send us your friend so that we can also demonstrate to them what we have done. With this being said, thank you for attending today, and now we will open it for any questions that you have. Thank you.
Thanks.